Here's another question and answer. This one's about finding the number of inflection points of a function in a tech-active context. This is a question from one of the external exams, so I'll give you a chance to have a read of it and also look at some syllabus definitions. So in this problem, we are given the first derivative of a function and told its domain, and we're asked to find the number of points of inflection that the original graph has on that interval. So those two syllabus definitions combined essentially means that the point of inflection occurs when the second derivative changes sign, either from positive to negative or negative to positive. So just so we can understand outside of the context of the problem, this point here, we're curious whether it's a point of inflection. So we differentiate it and then differentiate it again, and we see that from this point, the second derivative, which is the concavity, changes from negative to positive. So this one is a point of inflection. Whereas on the graph of y equals x to the power 4, we can differentiate it twice. Here's my point here, the second derivative is 0, but on both sides of it, the concavity is positive. So the concavity hasn't actually changed sign. It's still the same sign. It's positive both sides of that inflection point. So this one is not a point of inflection. So let's go back and have a go at the actual problem. So in terms of the information that I'm given, I know something about this middle function, the first derivative. I don't know anything about the actual function, but that's okay. We're not going to worry about that at all. All we're going to do is use the information in the graph in the question to graph the second derivative and then see where there's some sign changes. So to get the second derivative, I need to differentiate the first derivative again, and I'll just do this with chain rule. So differentiating sine goes to cosine, then multiplying by the derivative of x cubed, which is 3x squared. So I really just want to get my graphics calculator out, graph that function, and see how many times the derivative changes sign. So I'll type this into my graphics calculator, and I'll get something really funky looking, which means, hey, I just need to change my domain to what it is in the question, minus 1.8 to 1.8. And that looks a little bit better. So I'm looking at this graph, seeing that there is one point where it goes from positive to negative. This is the graph of the concavity. Another point where it goes from negative to positive. This point is not a point of inflection because the concavity is positive both sides of that point, so I won't select that one. Here's another point of inflection, and here's another point of inflection. Okay, so the solution is 4 points of inflection. So the answer to the question should be C. Because that middle point was such a distracting thing, when you look at the solutions to this problem, I think QCAA actually accepts answer 5 as well. But definitely the answer is 4, and in a short answer response, you get penalized for classifying that origin as a point of inflection. One other thing that we should remember is that sometimes this function is really hard to differentiate. So in a tech-active context, we don't actually need to differentiate it at all. We can just differentiate it on our calculator and get the same result. So I should be able to differentiate this directly. Okay, and I get exactly the same function. So just make sure you can use your calculator to graph derivatives straight up, and make sure you remember that real definition of a point of inflection. Okay, good luck.